All right, here is part 2 of section 4 from this redesigned SAT practice test 1. So this is the calculator section of the math portion. In part 1, my part 1 video, I did problems 1 through 10, as you can kind of see here. So in this video, I'll pick it up with number 11, which is this inequality problem. Which of the following numbers is not a solution of this inequality? Few ways you could solve this one. One thing you could do is you could just plug these values in for x and figure out which ones yield true statements and which one yields a false statement, because I'm looking for which one is not a solution. Sure, that's one way you could do it. Another way you could do it, since you probably don't need me showing you how to plug numbers into a calculator, is you could solve this. The way you solve an inequality is a lot like how you solve an equality. The only difference is that if you ever divide both sides of an equation or multiply both sides of the equation, or inequality, I guess, by a negative number, you got to flip this sign around. So it's currently greater than or equals. You change it so that it's less than or equals, if you happen to do that. So to avoid doing that, what I'm going to do is I'm going to subtract 3x from both sides of the equation. Sorry, inequality. So this 3x goes away, and 4x minus 3x is x. It gets me here. And then if I add 3 to both sides of the inequality, I get negative 2 is less than or equal to x. In other words, negative 2 is greater than or equal to x. In other words, x is less than or equal to negative 2. X must be to the left of negative 2 on the number line, or be equal to negative 2 in order for it to be a solution. But remember, what I'm looking for is what number is not a solution. So negative 2 is less than or equal to negative 2, so that's not a solution. Negative 3 is to the left on the number line, that's less than negative 2, so that's not a solution. Negative 5 is to the left, that's not a solution. It looks like my answer here would be negative 1. Sure enough, negative 1 is to the right of negative 2 on a number line, right? There's negative 2, there's negative 1. What I am saying is the solutions to this guy is this number and all numbers that way. Negative 1 is not in that range. Therefore, negative 1 is not a solution. Number 12. Got a graph. The number of seeds in each of 12 apples. I'm giving kind of this histogram here. Sure enough, based on the histogram above, which is the closest to the average number of seeds per apple. Okay, so the average. To figure out the average, you add up all your observations and you divide by 2. So I have 12 observations here. I say divide by 2? Sorry, you divide by 12. You divide by the number of observations you have. So it looks like twice I had 3 seeds. So I got 3 plus 3. It looks like 4 times I had 5 seeds. Looks like 1 time I had 6 seeds, 2 times I had 7 seeds, and 3 times I had 9 seeds. So you could add all these numbers up with your calculator, or you could just say, well, that's 6, that's 20, that's 6, that's 14, and that's 27. So that gives me 20 there. So these guys give me 40, and these two give me 33. So it looks like I got 73 in total divided by 12 to calculate my mean. And 73 over 12, I guess you could do that in your head if you really felt like it, but you do have a calculator, so maybe punch that in. 73 over 12 gives you just over 6, which is the closest to 6.08. 6 is. So my answer would be 6. And that makes sense here if you kind of look at these guys. These guys are 1 more than 6. These guys are 1 less than 6. So I have more that are less than 6 than more than. But then these guys are 3 more than 6. These guys are 3 less than 6. So it looks like my average is going to be something pretty close to 6. Sure enough, that answer ends up being the answer. 13, you're given this table here, and you're told a group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. Survey data were broken down as shown above. Which of the following categories amounts for approximately 19% of all survey respondents? So note that I have students here. There's 310 total. And those students could have been taking Algebra 1, Geometry, Algebra 2, and they could be male, female, so they could fit into any of these spots here. 310 total. I want approximately 19% of everybody. If I take 19%, in other words 0.19, and I multiply it by 310, I can figure out how many students account for 19% of the total. and that gives me 58.9. In other words, damn near 59. So what I'm looking for is a 59, or a number that's really close to 59. Hey, there's exactly 59 right there. That's nice. What does this represent? This represents the males that are taking geometry. So if you go here and read part C, it says the males taking geometry. That looks like it's really close to 59%. That would be my answer. I think a natural way to do this would be to take each of these numbers and divide them by 310 to get the percent, and then compare those percentages to 19. But I think it's quicker to go about it this way, right? Just do the calculation once instead of 4, or I guess 6 different times. There's 13. 14. The table above shows the length to the nearest inch of a random sample of 21 brown bullhead fish. Okay, they're ordered, which is kind of nice. There's 21 here, so 7 in each row. Looks like I got a lot, ranging from 8 up to 24. And then what I am told is that there's this outlier here. This 24 is significantly more than any other of the fish. That's a huge fish right there, apparently. And what I'm asked is, which will change the most if this guy is removed? The mean, the median, or the range? Option 1 is to calculate the mean, the median, and the range with this observation in there, and then to recalculate the mean, the median, and the range with this outlier removed, and see what changes the most. That'll take you a long time. I don't recommend doing that. If you can think about this, you can come up with the correct answer, which will end up being the range here, by kind of going through this logic. First, the mean. The way you calculate the mean is you add up all of these numbers, all 21 of these, and then you divide by 21. So I get that mean. I don't know exactly what that number is, but it's some number that I get when I add all these guys up and then divide by 21. If this observation weren't in there, I would add up all these guys and divide by 20. That's not going to be all that much different, right? All of these numbers divided by 21 versus all of these numbers divided by 20. Yeah, it'll change it a little bit. My mean is going to get smaller when I remove this outlier. But the average is taken of all 21 of these fish. So just getting rid of one of them is not going to change the mean very much. This is going to be changed by, I don't know, approximately an inch or so. The median is your middle observation. If I have 21 fish, my middle one would be the 11th observation. You can get that by adding 1. The median is the n plus 1 over 2, kind of that observation. This is your median. So 21 plus 1 gives me 22, divided by 2 gives me 11. The 11th largest observation. There's 7, 8, 9, 10, 11. This is currently my median, if I have all 21 of these guys. If I get rid of this guy, then my median would be the average of my 10th and 11th observations, which are these two guys right there. But note that the average of 12 and 12 is the exact same as just 12. So what ends up happening is the median does not change at all. The median doesn't equal 0. Maybe the change in the median equals 0, whereas the change in the mean is about 1. What about the range? The range is just the difference between your largest observation and your smallest observation. So my initial range is the difference between 24 and 8. It turns out that number is 16. But you don't even need to know that number is 16, because my new range will be the difference between the now largest number, if this is gone, which is 6, and 8. And that difference is only 8. That difference is a lot less than this difference. The distance from 8 to 24 is far. The distance from 8 to 16 is not as far. This is going to change by 8, significantly more than either of those will change by. Your answer will be C. 15. You're given this graph, this linear equation, which shows up over and over in these SAT tests. And you're told 15 and 16 refer to this. This is the total cost of renting a boat by hour. In other words, if you want to rent a boat, you're paying $5 no matter what. And then every extra hour you keep the boat, it looks like the cost you pay an extra, $3. So $5 if I just rent it and give it right back. But if I keep it for an hour, it's $8. For another hour, so 2 hours total, we're up to $11 and so on. What does the C-intercept represent in the graph? Okay, so they're asking this height right here of 5, because this axis is my C-axis, because it's labeled with the C right here. What does that represent? What does that 5 mean? Well, like I just said, that's how much you have to pay immediately, the second you get the boat. That's how much it would cost you to rent this boat and then turn around and give it right back to the dude. The initial cost of renting the boat? Sounds good to me. Total number of boats? No. Total number of hours? No. The increase in cost? That's close. That's the slope. That's how much this increases every time I take one step to the right. Really, there's two relevant things. And I wouldn't even be surprised if 16 asks about the other one. The slope and the intercept. This one's talking about the intercept, so the answer is A. 16 says, which of the following represents the relationship between H and C? In other words, this line right here, can you come up with this equation? Well, maybe when you're thinking about the equation of the line, you're thinking y equals mx plus b. That's good if you're thinking that, m being the slope and b being the y-intercept. It's good. However, in this case, it's not a y, it's a c. Okay, fine. And it's not an x, it's a h. Okay. But b and m still represent the same things they represent up here. The m represents the slope, and the b represents the y, or c in this case, intercept. So my value of b is just a 5. And my value of m, that's my slope. How much do I go up every time I take one step to the right? The answer to that question is 3. So the equation of this line is c equals 3h plus 5. Look for that guy over here. There it is. That's my answer. 17, you're given this graph, y equals f of x. The complete graph of this function is shown in the xy plane above. For what value of x is the value of f of x at its minimum? F of x is the y-coordinate. It's the height. It's the up and down of the graph. Whereas the x-coordinate is the left and right of the graph. So you can probably stare at this thing and be like, oh, here it is. There's the minimum. But be careful. It's not asking what is this height, which is -2. It's asking what value of x will give you this height. I bet a lot of people put -2 as their answer. That's not the answer. That is the height. But the value of x that gives you that height is this x-coordinate, -1, 2, 3 here. So when x equals -3, this point has an x-coordinate of -3 and a y-coordinate of -2. What you want is the x. Your answer is -3. 18. All right, number 18. 18 is a little bit tricky here. So you're given these inequalities, and you're told that 0, 0 is a solution to this system of inequalities. And what you're asked is which of the following relationships between A and B must be true? Okay, so there's a few different ways you can solve this problem. One way you could do it is you could say, well, I know that y is greater than x plus b, and I know that y is less than -x plus a. So what that tells me is -x plus a must be greater than x plus b. So I can mess with this a little bit, and I can say, okay, a must be greater than 2x plus b. This must be true right here. A must be greater than 2x plus b. But you're like, well, wait a minute. What is x? What's going on here? Well, note that 0, 0 is a solution. So what I'm saying is that when x equals 0, I get a solution to this equation. If x equals 0, then I got that a is greater than b. Right? The 2x, 2 times 0 is just 0. I get a is greater than b, which would be answer A right here. Here's a way to solve it algebraically. That might not be too satisfying. You might not like that way. Here's a way to solve it graphically. I kind of like the graphical solution better, but it's because I'm a very visual person. I like to look at these equations kind of as lines. So think about it as y equals mx plus b. The top one would be y is less than -1x plus a. My slope is -1 and my y-intercept is a. You're like, how the hell are you going to graph that line? You don't know where a is. That's true, but I do know that the slope of this line is -1. So it's kind of diagonal down and to the right. And I have to make sure that 0, 0 is in my solution set. And since I have y is less than this value, I'm going to shade everything that is below this line. So I got to draw a line and then shade everything below it. And I need 0, 0 to be in that shaded region. So if I'm going to have 0, 0 in that shaded region, I better make sure that a is some positive number. A is somewhere up here. And then later on, I'll go and shade all this stuff below it. Maybe I'll shade later on. So I don't know exactly where a is, but I do know that a is positive so that I include this point in my solution set. Similarly, I got y is greater than 1x plus b. So now my slope is +1, so it's diagonal up and to the right, and my y-intercept is b. But since y is greater than this thing, I want to shade above this line. So I'm going to draw this line, I'm going to shade above it, but in the shaded region, I better contain this point here. So really what ends up happening is this blue line right here has to have a y-intercept that has a negative value. So the region that is shaded below the red line and above the green line is this. So for the picture that I drew, this shaded green region is my solution set, and note that that includes that point. So okay, here's kind of what's going on in the problem. Which of these statements corresponds with that? Does A have to be greater than B? Absolutely it does, because B has to be less than 0, and A has to be greater than 0. So A has to be greater than B. That's true. You can get that from this picture if you don't like the algebraic way. Does B have to be greater than A? No. I mean, here's a picture. It's not. B is less than A. What about the absolute value of A being greater than the absolute value of B? Not necessarily, right? This blue line could be way the hell down here. Then B is further away from 0, that distance, than A is from 0. But I'd still have this point in my shaded region. So that's not right either. A has to be equal to negative B. That's tempting to do that one. It almost looks like it in the picture. But again, consider the case where I drew B way the hell down here. Right now B is, I don't know, -8. We're up here. A is +1, for example. It's not true that it has to be equal to the -1. I can get rid of that one and call this my answer. All right, maybe that was more than you needed on that one. Number 19, a food truck sells salads for $6.50, drinks for $2. The food truck's revenue from selling a total of 209 salads and drinks in one day was this number. How many salads were sold that day? This is a system of linear equations. You sell salads for $6.50. So if I let S represent the number of salads that I sell, the number of and D represent the number of drinks that I sell, this statement tells me that I sold a total of 209 salads and drinks. And then I'm going to come up with another statement that kind of has to do with the revenue. Each time I sell a salad, I sell them for $6.50. So the total amount of money I make from salads is 6.5 times S. The total amount of money I make from drinks is 2 times D. And the total amount of money I make is $836.50. So I have these two equations. What I want to do is solve them. I want to know how many salads were sold that day, so I want to solve for S. So I would like to get rid of D. The easiest way to get rid of D is to take the top equation and to multiply it by -2. So you get -2S minus 2D equals -418. And if that came from my top equation here, multiplying by -2. Now my bottom equation, I'm just going to leave it alone. 6.5S plus 2D is equal to $836.50. Note that now if I add up these equations, which is a really handy trick, that comes into play a lot on SAT tests, the D's go away. I have 6.5 minus 2, so I have 4.5 of these S's. And then I have 836.5 minus 418. I suppose you could pull out a calculator and you'd figure out that that's 418.50. And so what you want to do is figure out what is 418.50 divided by 4.5. And maybe we'll finally resort to my calculator here. 418.5 divided by 4.5. And what you get is 93. And you'll look up here for salads, 93. That's your answer. And that works for 19. FYI, you could get there another way. This is my salads column. You could figure out my drinks column. Right? If I sold 77 salads, then 209 minus 77 would be how many drinks I sold. I sold 132 drinks. And if I sold 209 total and 93 of them were salads, then I sold, 112? Better to use my calculator. 209 minus, what did I say, 93? Then 116, good thing I checked, drinks. And if you sold 99, you'd get 122 here. And if you sold 105, man, I can't do simple arithmetic. Good thing I got a calculator here. I'd get 110. Yeah, jeez. I would have sold 110 drinks. And if I got 105, I would have sold 104 drinks. In order to make sure that I sell 209 total, this is how much of each I would have had to sell. So if you take this number and multiply it by 650, and then you take this number and multiply it by 2, you can check to see if you get 836.50. You could do that. I think it would probably end up taking you a little bit longer, but that would be a way to avoid doing these calculations. However, if you can do this addition trick here, this system of linear equations, adding the equations, I think it's quicker. All right, last one, number 20. Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? So P is what she actually paid. What she paid is, let's see, I'm going to say the price of the computer is maybe C. So the original price of the computer, she got 20% off. So she only paid 80% of the original price of the computer. C is what it originally cost. 20% less than that is the 80% she paid. So this was the amount she was charged. Then she had to pay tax. Taxman got her. Taxman says takes that amount and multiply it by 1.08. So what she paid is this amount. What the question is asking is which of the following represents the original price of the computer? What is C in terms of P? So what you want to do is solve this equation for C. How do you get the C all by itself? Well, I could divide both sides of the equation by the 0.8 and by the 1.08. And then I would have C in terms of P. I would get that P is equal to, or C is equal to P over 0.8 times 1.08, which looks like that's answer D here. That's one way you could do this problem. Another way you could do this problem is choose some nice round numbers. Maybe her laptop, she bought it $100, let's say. Let's say that the original price was $100. She got 20% off. So original price is $100. She got 20% off sales price. She got 20% off. It sounds like she paid $80. Tax, including tax price. How about that? Including tax sales price. Well, I'd have to take that 80 and multiply it by 1.08. And that gives me $86.40. Okay, so this is the amount she paid. This was the original price. So the question is, how can I express which of the following represents the original price, 100, in terms of 86.4? So you're starting with 86.4. This is P, and you're plugging that in and figuring out which of these equations would give you, which of these expressions, would equal 100 if P were equal to 86.4. 86.4 times 0.88, if you multiply by 0.88, that's making it smaller. That's certainly not going to make it 100. If you divide by 0.88, it's going to get close, but in order to make it 100, I'd have to divide by 0.864, so that's not going to quite work either. This one, I'm multiplying by 0.8 and then multiplying by 1.08, so try that. Try that with 86.4. Multiply it by 0.8, you'll get something in like the $66 range, and then multiply by 1.08, you'll get up to like $70, give or take. That's not 100, so that's not the answer either. Try it here. Try taking that 86.4, dividing by 0.08 times 1.08, and you'll get exactly the 100. So if this algebra confused you, you can kind of give yourself an example and then check which answer works. I think I'll call that good.